The Kiten was conceived as a weapon that would restore initiative to a losing navy. In practice, it exposed the limits of sacrifice in an era defined by industrial warfare. Courage was never in short supply. The pilots who entered those narrow holes understood their fate with absolute clarity. They acted not out of ignorance, but out of duty to their commanders, to their comrades, and to their country. Their resolve was real, their loss was irreversible, yet history is unforgiving when strategy collapses. No amount of personal bravery could compensate for inadequate intelligence, shrinking resources, or the overwhelming production capacity of an enemy operating at full strength. The Kiten demonstrated that when a nation turns to weapons that demand certainty of death, it is often responding not to opportunity, but to the absence of viable choices. In the decades that followed, naval warfare moved decisively in the opposite direction. Automation increased. Standoff weapons replaced close-range attacks. Protecting trained personnel became a strategic priority rather than a secondary concern. In this sense, the Kiten did shape the future by serving as a warning. It showed what modern militaries must avoid, even under extreme pressure. The true legacy of the Kiten lies not in the ships it sank, but in the questions it forces us to confront. How does a society measure victory when survival itself is no longer part of the mission? At what point does loyalty become exploitation? And how many lives can be spent before the meaning of sacrifice is hollowed out? For historians and military professionals alike, the Kiten stands as a somber reminder that wars are not only won by technology or numbers, but by the decisions that preserve or squander human potential. The ocean has long since closed over those steel holes, but the lessons they carry remain painfully relevant. It was in this atmosphere of collapse that German engineers were asked to do the impossible. The requirement was simple on paper, but brutal in reality. Create an aircraft fast enough to outrun Allied fighters, capable of striking bombers or ground targets, and able to operate from short, damaged airstrips. This was not innovation for dominance, it was innovation for survival. The answer came from an unconventional direction. Rather than refining existing designs, the Horten brothers pursued a radical concept they had believed in for years: the flying wing. By eliminating the traditional fuselage and tail, they sought to reduce drag to an absolute minimum. Every unnecessary surface was removed. What remained was pure lift and speed, shaped by aerodynamic theory rather than tradition. This philosophy directly shaped the Horten Ho 229. Unlike other German aircraft of the period, it relied heavily on wood for its construction. This was not an aesthetic choice, nor an early nod to stealth, but a harsh necessity. Strategic metals were scarce. High-grade aluminum alloys were increasingly unavailable. Wood, particularly laminated beech plywood, was abundant, lightweight, and strong enough for the task. In wartime Germany, practicality trumped elegance. Jet propulsion was the other critical piece. Piston engines had reached their limits, and Germany's early adoption of jet engines offered a narrow technological advantage. The Ho 229 was designed around this idea from the start, integrating its engines directly into the wing structure. This allowed for a compact profile and reduced drag, but it also introduced significant engineering challenges, especially in cooling, maintenance, and reliability. The aircraft was conceived as both a fighter and a light bomber. In theory, it could intercept Allied bombers at unprecedented speeds or penetrate defenses carrying bombs of its own. On paper, its performance figures were astonishing. In practice, however, the project raced against a clock that could not be stopped. Germany no longer had the time to refine prototypes, train pilots, or solve the countless problems that emerge only through operational use. The Horten Ho 229 was not born into a stable development program. It was thrust into existence during the final convulsions of a collapsing war effort. Its origins were defined as much by desperation as by brilliance. At the heart of the Horten Ho 229 lay a promise that seemed almost impossible for its era: speed without compromise. Its flying wing configuration was not merely unconventional, it was mathematically elegant. By merging wing and fuselage into a single lifting surface, the aircraft minimized drag and maximized aerodynamic efficiency. In theory, this allowed it to approach speeds that no operational Allied aircraft could reliably match. The wing itself was sharply swept and angled upward with a modest dihedral, providing inherent stability during roll. Yet the absence of a traditional tail introduced a dangerous trade-off. Without a vertical stabilizer, the aircraft became inherently unstable in yaw. To compensate, engineers layered the design with an intricate network of control surfaces: elevons, flaps, spoilers, and drag rudders, each performing multiple roles simultaneously. This was a solution born of ingenuity, but also of necessity. In an age before digital flight controls, every correction depended entirely on the pilot. Small errors could cascade into uncontrollable motion. The aircraft demanded constant attention, precise inputs, and exceptional skill. While the design was decades ahead conceptually, it relied on human reflexes to perform tasks that modern aircraft would later delegate to computers. The result was an airframe that could perform extraordinary maneuvers, but only at the edge of what a pilot could safely manage. Power came from two early-generation jet engines mounted within the wing structure. These engines offered remarkable thrust for their time, pushing the aircraft close to the design target of nearly 1,000 kilometers per hour. On paper, this placed the Ho 229 beyond the reach of escort fighters, such as the P-51 Mustang, and faster than the Spitfire at altitude. Against bomber formations, it would have been a terrifying interceptor. But speed carried a cost. The engines were fuel-hungry, limiting operational range. More critically, material shortages forced German manufacturers to use lower-quality steel in turbine components. As a result, engine lifespan was measured not in hundreds of hours, but in mere dozens. Overheating, fatigue, and failure were constant threats. This was cutting-edge technology built under collapsing industrial conditions. The aircraft's projected performance figures were extraordinary. Rapid acceleration, high maneuverability, and the ability to operate from short, damaged runways. These capabilities addressed real battlefield problems Germany faced in 1945. Yet none of them had been validated under combat conditions. The Ho 229 existed in a narrow space between theory and reality, where calculations promised dominance but history offered no time for proof. By the time the Horten Ho 229 began to resemble a viable combat aircraft, the war it was meant to fight was already slipping beyond reach. Only two prototypes had ever taken to the air, and while their test flights demonstrated promise, they also revealed the harsh limits of rushing revolutionary technology into existence under catastrophic conditions. The third prototype, the V3, was intended to be the first truly combat-capable version. It was here that armament, refined systems, and operational details were meant to converge. But history intervened. In April 1945, as Allied forces advanced deep into Germany, the unfinished V3 was captured by the U.S. Army. It never flew. It never fired a shot. Whatever role it might have played in the air war ended quietly, on the ground, amid the collapse of the regime that had demanded its creation. The reasons were not difficult to identify. Germany no longer possessed the industrial stability required to support such an advanced aircraft. Jet engines failed too quickly. Skilled labor was scarce. Fuel was rationed to the point of paralysis. Even if the Ho 229 had entered limited service, maintaining it in combat conditions would have been a logistical nightmare. Revolutionary designs do not thrive without infrastructure, training, and time-3 resources Germany had already exhausted. There were also fundamental operational risks. The aircraft's complex control system, combined with the absence of computerized stabilization, placed extraordinary strain on the pilot. In experienced hands, the Ho 229 could maneuver with remarkable agility. In less capable ones, it bordered on lethality. Studies conducted after the war suggested that while the airframe itself could withstand extreme forces, the human body could not. At the edge of its performance envelope, survival depended more on physiology than engineering. When the war ended, so did the project. There were no squadrons waiting to be equipped, no pilots trained to master its demands, no opportunity to refine flaws through combat experience. The Ho 229 became one of history's many what-ifs, a machine, defined not by what it achieved but by what it suggested. Its failure was not one of imagination or ambition. It failed because it arrived too late, in a nation already broken by strategic defeat. The aircraft represented a future of air combat that would eventually come to pass, but not in the hands of those who conceived it. The war closed the door before the Horten Ho 229 ever had the chance to step through. After the war, the Horten Ho 229 entered a new phase of existence, one defined not by combat but by examination. In American hands, the unfinished V3 prototype was no longer a weapon of desperation. It became a subject of study, stripped of ideology, and evaluated through the lens of engineering and future potential. What the United States found was neither a miracle nor a myth, but something more nuanced. For decades, speculations surrounded the aircraft's unusual shape, its smooth surfaces, lack of vertical stabilizers, and blended wing-body design led many to claim it was the world's first stealth aircraft. The idea was compelling. Radar technology during World War II was crude by modern standards, and anything that reduced reflections could, in theory, delay detection. Even one of the Horten brothers later suggested that charcoal-infused materials had been considered to absorb radar energy. But speculation is not evidence. In 2008, the aircraft's legend faced modern scrutiny. A full-scale reproduction of the Ho 229 was tested using contemporary radar analysis in collaboration with aerospace engineers who understood stealth not as rumor, but as physics. The results were clear. While the design may have offered a modest reduction in radar visibility compared to conventional aircraft of its era, it did not meet the criteria of stealth as it is defined today. True stealth requires more than shape alone. It depends on precise materials, internal weapon bays, edge alignment, and most importantly, computer-controlled flight systems, capable of managing inherently unstable designs. These were technologies that simply did not exist in the 1940 seconds. The Horten Ho 229 hinted at the future, but it could not reach it on its own. From an American perspective, the aircraft's real value lay elsewhere. It demonstrated that radical aerodynamic thinking could unlock entirely new performance envelopes. Decades later, when long-range stealth bombers finally entered service, they did so with many of the same conceptual foundations but supported by digital flight controls, advanced composites, and a stable industrial base. The Ho 229 did not fail because it lacked vision. On the contrary, it suffered because its vision exceeded the limits of its era. Its designers imagined an aircraft shaped purely by physics, liberated from tradition, optimized for speed and efficiency, in a way that would not be fully realized until computers could shoulder the burden of flight control. In 1945, that future was still decades away. What makes the story of the Horten Ho 229 endure is not the myth of stealth or the fantasy of a war-changing superweapon. It is the reminder that technological brilliance cannot reverse strategic collapse. No aircraft, no matter how advanced, can compensate for exhausted industry, lost air superiority, or a war already decided by economics and manpower. Innovation can shape the future, but it cannot rewrite the present. And yet, the aircraft was not meaningless. Its ideas survived. Long after the Reich fell, those same aerodynamic principles resurfaced, this time supported by stable institutions, advanced materials, and digital control systems. The flying wing would return, not as an experiment born of desperation, but as a mature solution to modern strategic requirements. Today, the preserved prototype stands not as a weapon, but as a lesson. It speaks quietly of what happens when human creativity races against history and loses by mere months. It also reminds us that progress often arrives in fragments, carried forward by those who study the past rather than repeat it.